Hello, welcome. I am very excited that this is another guest tutorial video. And today's guest is, and I meant to ring the bell after I said her name, Emily Xie. She is here in the studio, and she just did a tutorial building exactly this, what you see behind me, which if you don't recognize, is visualization mirroring the rain effect in the movie The Matrix, Matrix Rain. So this is really wonderful. It's a perfect thing to use p5.js for, and there's a lot of creative possibilities that I hope that after you watch the tutorial, you will make and share. So a couple things I want to mention. Number one, if you're looking for the source code for this tutorial, if you're looking for Emily's Twitter to share what you make with her, everything will be in this video's description. I also want to mention for a bunch of you viewers here who have always asked me to please use for each loops. You will finally see on the coding train some for each loops in this particular video because Emily very smartly is using them. So without further ado, I will leave this screen and you will then see the tutorial starting from Emily. Oh, I wanted to say a few things about Emily. So Emily is a creative coder and artist. She has done workshops and other projects with organizations, great organizations like Girl Develop It and Pioneer Works in Brooklyn. And she's also currently working for Squarespace. So you can find out more about her if you check out her Twitter and her website, which will also be linked in this video's description. Okay, now just enjoy the tutorial. Okay, thanks, bye.
So hey everyone, and thanks for the wonderful intro, Dan. I'm super excited to be here, especially as someone who's been following this YouTube channel for a while now. So for today's tutorial, we're going to be recreating that iconic matrix raining code using p5.js. And for those of you who have never seen the Matrix series before or don't know what it is that I'm talking about, have no fear. I'm going to play the clip from the movie to clarify. Cool, so that raining green code, this right here, this is what we're going to be recreating using p5. And in terms of background level, I'm going to teach with the assumption that you have some basic understanding of object-oriented programming, and maybe you've written a few simple p5 sketches, maybe you've seen some of Dan's videos on this channel, or maybe you've just sort of explored the library yourself. Anyway, let's jump right in. So here is my sketch file where all of the p5 magic will happen. And right now it's empty, but let's fill it in with our two core p5 functions. Setup being one of them. And as some of you might know, this is the function that gets invoked once immediately upon loading up your sketch. And I know I'll also need the function draw, which some of you might also know is the function that gets called repeatedly at 60 frames per second as your sketch runs. So now that I have these down, let's start first by fleshing out setup. So inside of this function, I'm going to make my canvas so as to carve out where on the web page I want my sketch to be. So we're going to use the function createCanvas. And I actually want this sketch to span the entire page. So for the width argument, I'm going to pass in window.innerWidth. And this returns the width of your browser's entire content area. And for the height, I'm going to pass in window.innerHeight, which you might be able to guess returns the height of your browser's content area. Cool. So I know I also want my background to be black, so let's go ahead and set that to 0. And let's run this. There we go. Awesome. So we have our initial setup, which I blend entirely into. So this is the scene where we'll make the matrix raining code happen. So now let's take a step back and think about the sketch at a higher level. And let's sort of consider what might be some of the general components or classes here. So if we look at this, at the matrix, if we look at the screenshot here, I can sort of sense that there are going to be two primary object types. One of them being the symbol, so it's like each one of these characters individually, and the other one being the stream object. So a stream being like one of these vertical lines comprised of symbols. So let's go back to our code and let's stub out these prototypes. And by the way, I'm probably going to use the term prototype and class interchangeably here. So if we go to our code and stub out symbol, there we go, and our stream. Here we go. So let's start off with our symbol class and make just one symbol and show it for now. And we'll get to the stream class a little bit later, so I'm just going to go ahead and move it down a bit. So for your symbol, you're going to need an X and a Y to show the location on the canvas, both of which we pass into this signature here. And then let's add these properties. So this dot x equals x, this dot y equals y. And we also want a variable to hold the actual symbol itself. And we'll call this value. And this will be set later on using this function, set to random symbol. Okay, so what will go into this function? What should each symbol get set to? So if you take a look at the matrix, you'll see that the symbols are in fact comprised largely of katakana, which are characters that represent syllables in Japanese and Ainu. Ainu being an indigenous ethnic group living in Hokkaido and Russia. So that's your bit of trivia for the day. So how do we represent these characters? Our keyboards won't let us type in katakana. So what do? Well, simply enough, we will use Unicode, which is a numeric encoding, in order to represent them. And pictured here is all of the katakana in the katakana Unicode block, and there are 96 total. So let's go to our code and write our function to randomly retrieve one of these beautiful symbols. Here we go. And I'm actually just going to write this out, and I'll explain it in a bit. So this dot value equals string dot from char code. Okay, there we go. We're going to pass in 0, x3 0a0 plus round it to a random number 096. Okay, so that looks about right. So the katakana Unicode block starts at encoding 0x30a0, which translates numerically to 12448, which will then be added to a random whole number between 0 and 96, because there are 96 available characters in the katakana Unicode block. And then whatever number results from this addition will be passed into this function from char code, and finally converted into a string containing your katakana character and set to this dot value. Okay? So now that we have the code to retrieve and set our symbol, let's write a function to actually display it on our canvas. And we'll call it render. I'm just going to scroll down a little bit for everybody to see. So we'll use the text function to actually display our symbol. And we know that the symbol is contained in this dot value, and we want to display it at coordinates x and coordinates x and y. And we'll fill it with colors 0 for red, 255 for green, because we want it green. But we also don't want it too green, so maybe we can, I don't know, add a little bit of blue in there. So maybe like a blue value of 70 might look nice. Great, so now let's set things up so that we can create our symbol and render it. So if we go back up here, at the top of our code, let's set a global variable to hold that symbol. We'll call it symbol. And since it's global, we can access this variable anywhere in our global scope. And now, down in our setup function, let's stick an instance of our symbol into that global variable. So symbol equals new symbol, okay? And for now, we'll display the symbol smack dab in the middle of the screen, the canvas, just for demonstration purposes. So we'll set the x value to width divided by 2, and the y value to height divided by 2. And now, within the draw function, we should probably set the symbol's value. Symbol.set to random symbol. There we go. And now, within our draw function, let's render it. Symbol dot, oops, typos, render. Okay, and let's play. Okay, so I've made a mistake somewhere. Let me go ahead and inspect my code. So it says somewhere on line 12 that there's an unexpected token. Ah, I have an extra comma here. So I'm going to fix that. And now I'm going to replay this. Okay, awesome. So now we generate a random katakana character, but actually it's a little bit small. I'm not even sure if you can see it. So let's go to our code and increase the size of the symbol. And we'll do that by creating a global variable called symbol size. And let's set it to something huge, just so that we can see. So I think maybe 60. And now within our setup, let's actually set the text size here. Text size, I believe, is the function, to our symbol size. And now I'm going to refresh. Okay, fantastic. So now we generate a random katakana character whenever we load up our sketch. And if you refresh, so I'm just going to refresh here, you'll see that you get a new one every single time. However, in the matrix, the symbols don't just sit there in the middle of the page. They rain down. So let's go ahead and write some code to do just that. So let's go back to our sketch file. And if we go back to our symbol class, let's add a speed value here to determine the rate at which this symbol falls. So speed will get passed in, and the speed property will get set as what gets passed in. And let's write a function to actually make the symbol rain down. And I think an appropriate name would be, I don't know, rain. Okay. And inside this function, all we're going to do really is increment the y position of the symbol object according to the speed so as to make the symbol slowly move down the page. So this dot y plus equals this dot speed. Okay. And now within render, let's pass in a random speed. Now within our render function, since this is what gets invoked on every frame via draw, let's make it rain. So this dot rain. Great. And now back in our setup, let's pass in a random speed whenever we create this new symbol object. So for now, let's say we'll give it a ballpark of 5 to 10, so it'll be randomly generated. But let's also switch the y value out, so it's not halfway down the page. Let's have the let's have the symbol start at the top of the canvas. So we'll set y to 0. Okay, so let's go ahead and refresh this. Okay, voila! So we now have a symbol that rains down the page. But we actually want to redraw the background on every frame so that it erases this trail, because this isn't what the matrix looks like. So let's go to our code, and let's go to background. Let's go to draw, and let's stick a background in there. Okay. And now let's replay this. Okay, great. So now we have a symbol that rains down. But once this character reaches the bottom of the screen, we actually want it to loop back to the top and replay all over again, kind of like a GIF. So let's go to our code, and let's go to the rain function. Okay, and let's wrap this in a bit of a conditional. Let's wrap this increment. Okay, so if this dot y is greater than or equal to height, so if the y value is greater than the height of the canvas, this means that it's reached the bottom. So let's reset y to 0. Otherwise, let's just proceed as normal. Okay. And actually, we can make this look a little bit nicer using a ternary operator, which is just a syntax shortcut for this commonly occurring conditional pattern. So bear with me for a second. This dot y equals this dot y. Is it greater than or equal to height? If it is, then set it equal to 0. Otherwise, increment y with the speed. So this here and this here are the same, so I'm just going to get rid of that. And now we have some nicer looking code. So I'm just going to go ahead and replay this now. Okay, great. So now we have a symbol that rains down in a continuous loop in our matrix. But if we paid attention to that clip from the movie, we'll see that the symbols randomly switch to other symbols as it rains down. So let's go ahead and implement that. Let's go to our code. And let's go to our render function, since this is what gets called on every frame. And if you think about it, we've actually already written a function that allows us to switch from one character to another, and that is set to random symbol. So let's go ahead and just call that within this render function. Okay, so now I'm going to play this again. Okay, great. So it's switching to a new random symbol, but it's doing it way too fast. It kind of looks like a blur. You might not even be able to tell what this is. So instead of making it switch on every single frame, and there are 60 frames per second, let's do it according to a interval. Okay, so let's go back to our code, and let's go to the symbol class. And let's make this interval a property of the symbol class. So this dot switch interval seems like a pretty good name. And since we know that the switch interval should maybe differ a bit for every symbol, let's randomize it. So I'm going to randomize it to a whole number between, I don't know, 2 and 20, let's say. And now let's go to our setToRandomSymbol function and restrict the symbol being reset by the switch interval. And we can do that using a conditional. Let's wrap this all in a conditional. So if frame count, I'm just going to write this and I'll explain it in a second. Modulo this switch interval is equal to 0. I'll move this line of code up here, get some proper indentation there. Great. So frame count is a variable that is built into p5.js for you and keeps kind of this running tally of how many frames has passed thus far. And modulo is an operator that performs division and returns the remainder. So we perform a modulo on frame count using switch interval. And since we're looking for a remainder of 0 here, we're basically saying whenever the switch interval divides evenly into our frame count, then execute this line of code. So if switch interval were 15, this means that when the frame count is 0 or 15 or 30 or 45, the modulo will return a 0, and then we set a new symbol. So long story short, this code says to reset the symbol at every nth frame, n being your switch interval. So anyway, let's play this now. Great, okay. So now we have a symbol that rains down and switches to another symbol at a randomly determined interval. So now that we have our symbol class figured out, let's make it rain not just one symbol, but an entire stream of symbols. And since stream comprises of symbols, our symbols should live inside the stream class. So let's remove that single symbol that we stubbed out for demonstration purposes. I'm going to go into my setup, remove this, and remove this as a global variable. And now let's go to our stream class. It's all the way down here. Move this up a little bit. And let's add a property that contains an array that will hold all of our symbols for the stream. So this dot symbols is what we'll call it. And let's give it an array. And now thinking through some of what are the other attributes of what constitutes a stream, I think each stream should know how many symbols it has. So this dot total symbols, it's a pretty good name. And let's give it a range that it could randomly pick from so that each stream has a different number of symbols in it. So, I don't know, maybe some streams will be as short as 5 symbols and some streams will be as long as 30 symbols, and there'll just be streams of all sizes in between. Okay, and I also think that each stream should know how fast it's traveling at. So let's give it a speed property, and let's set it to a randomly determined one. Let's say somewhere between, I don't know, 5 and 20. And I also think it should be the responsibility of each stream to create all of its own symbols during the initial setup. So let's write a function to do that. And this function will use a loop to do all of that. So we'll call it generate symbols. Okay. There we go. And outside of our loop, we'll set a y variable that gets passed into our symbol objects. And we'll start it at 0 so that it starts at the top of the page. And for an x variable, let's also set that to, let's set it to a width. The width divided by 2 so that we see it, the stream at the top of our canvas in the middle, okay? All right, so let's write our loop. So here's our for loop. It looks more like this. Start it at 0, and we want to loop through however many symbols there are. That's how many times we'll loop through. And we'll increment our loop. And on every iteration, we should create a new symbol. So we'll pass in x, y, and the speed at which the stream is going. And right after we create the symbol, we're going to set the symbol's initial value. So set to random symbol. And then we're going to take that symbol and push it into the stream's symbol array so that it can live there. And then at the end of each loop, we also want to decrement y. Whoops, looks like this. We want to decrement y by the symbol size. There we go. So as to sort of set the next symbol immediately above it. So at the program start, if you were to render all of the symbols in the stream, what it would look like is, if here's the top of the canvas, the symbols would be stacked in a straight line above the canvas. And that's because y starts at 0 and gets decremented. And since it's the stream's responsibility to create its symbols, let's also give it the responsibility to display each symbol on the canvas. So let's write a function for this. We'll call it render. And we'll write a for each loop, looping through all of our symbols. And we're going to pass in an anonymous function and call each of the elements that we're iterating over, symbol. And we can actually copy and paste the code that we wrote in the symbol class, since we're transferring responsibility of rendering from the symbol to the stream. Okay, so let's copy and paste this, and let's also get rid of the remnants of this function. And then let's paste this. So let's indent things correctly. And since each element that we're iterating over is called symbol, we must change all of this to symbol. Okay, symbol.rain, and there we go. And by the way, keep in mind that there is more than one way to skin a cat. You can keep it so that it is the symbol's responsibility to render themselves and organize your code in such a way, but I prefer it this way, and I think ultimately it will make the code look just a little bit nicer and easier to read. So now that we have our stream class figured out, let's go back to the top of our code and write a global variable to hold our stream. So we'll call it stream. And then let's, in our setup, create our stream. So stream, okay. And then after we create it, let's instruct it to generate all of its symbols. And finally, in draw, let's render that stream. So, whoops, this symbol no longer exists. We're just going to render the stream. Okay, so let's load this thing up and see how we did. Okay, awesome. So now we have a stream that rains down repeatedly, and the stream contains characters that switch at their own randomly determined intervals. But as you may have observed, the matrix does not have just one stream. There are streams all the way across the screen. So let's go ahead and set things up so that our matrix is all the more exciting. So let's go to our code. And let's change the global variable so that instead of holding just one stream, it holds an array of streams. And let's give this an S, so it's streams, okay? And now in our setup, let's populate that array with a loop. So I'm just gonna go ahead and get rid of this one stream that we stubbed out. And outside of our loop, we're gonna have an X and a Y variable, which will inform the coordinates of each stream. So let's start them both off at 0. And now we loop. So start the loop at 0, and we're going to go until width divided by symbol size. And we want to divide the total width of the screen by the symbol size in order to get the total number of streams, since each stream is a symbol wide. So there we go. And now let's loop. So we're going to create a new stream on every iteration. And then instruct the stream to generate all of its symbols. There we go. And we originally hard-coded x and y into the generate symbols function, but since each stream will have a variable x and y that gets passed into it, we should just go in and let's go to that function and let's pass those variables into it, reflect that in the signature, and get rid of this x and y that we hard-coded. Okay, great. So now going back to our loop, where was it? Ah, here it is. So once we have our stream and all of its symbols, we'll push it into the mega array containing all of the streams. So streams dot push that one stream that we just made. And then we also want to increment where x starts, because we want each stream to start right next to the last one. So we'll increment by symbol size, because each stream, as you know, is a symbol wide. So now in draw, instead of rendering just that one stream, let's write a loop that will loop through all of our streams and render them all at once. So let's go to draw. Let's get rid of this, where we rendered just that one stream. And we'll write a for each on our streams mega array. And we're going to pass in a function. Each item that we iterate over on this in this loop will be called stream. Get rid of that. Okay. And every time we loop through, we're just going to, stream, there we go, render. Okay, so now I'm going to play this and see what happens. Oh, okay, so I've made a bit of a mistake here. Let me go into my console and try to figure that out. So I have an unexpected token on line 12. So line 12. Oh, okay, so I forgot to increment my loop. That's no good. So I think this should be all right now. Actually, I'm going to go ahead and change each symbol to just be a little bit smaller while I'm there. Let's change it to a size of 26. Okay. So let's try again. Okay, I'm going to close my console and let's see if this works. Great, okay, awesome. So there we have it. We have the basic effect down. This kind of looks like the matrix, right? And now I think it's just a matter of putting some finishing touches on this. So what do I want to change? Well, do you see how sort of on initial load, I'm just refreshing this for you to see, every single stream starts at the same y value of 0. I kind of want the streams to stagger as they come in. So let's go ahead and change that. Let's go back to our code. And on initial setup, let's go to our setup here. We're going to remove this y value, which is fixed at 0. And when we pass in to our generate symbols function here, we're actually going to pass in a randomized y start value. Okay, so let's call it random. Okay, so then instead of always starting at 0, maybe the stream will start somewhere between a y position of, let's say this is the top of the canvas, let's say between 0 and up to 500, negative 500. So let's code that in, negative 500. There we go. So I think, looks like, does that look right? I'm just going to split this up into several lines so I can better see it. There we go. That looks nice. Okay, so let's try again and let's see how that looks. Okay, great. So I do think this looks a little bit better, but I think even yet still, I think it can still be staggered a little bit more. So let's go into our code and let's change this random value minimum maybe to something even even smaller. So maybe like negative 1,000. So let's try that instead and see how that looks. Okay, fantastic. I think that looks great. So now we have this nice effect of the matrix more slowly trickling in. And for the next finishing touch, well, right now I think it looks a little bit too crisp for it to be the matrix. And if you look at it, so I'm just going to pull up the screenshot once again, the matrix has a little bit of a blur to it, right? So let's go ahead and let's change that. Let's do this. So I'm going to go into where the background is set. Where the background is drawn on each frame. And we're going to alter the opacity for this effect. So the default opacity for the background is set to 255. That's maximum. That's fully opaque. And if we pass in 2 parameters to background, then what will happen is P5 will interpret the second parameter as opacity level. So if 255 is fully opaque and 0 is transparent entirely, let's set it somewhere in between, I don't know, at 150, let's say. So I'm going to set that and let's play this again. Okay, ready? Great. Awesome. So now our matrix has this kind of this nice subtle glow effect. And this happens because each time the background redraws, the background is somewhat transparent, so some of the previous frame still shows through. And now going back to the sequence from the movie, the screenshot here, we also might notice how the tips of these streams are actually brighter in color than the rest of the stream, right? Kind of, I guess it's like a whitish green. So let's write something in our code to emulate this cool effect. So let's go back to our code. And let's go to the symbol class. Where is it? Here it is. Okay. And the way that we're going to do this is we're going to add a first property to this class right here. I'm going to pass this in. This dot first equals first. Let's set it. And this first property will inform the symbol. So the symbol will be cognizant of whether it's the first in a stream or not. So, and since it's the stream that creates these symbols, let's go there. So let's go to the stream class and let's specifically go to the generate symbols function, this right here. We'll set a variable called first outside of this loop. And we're going to set it to true. And then we're going to pass this in when we make our new symbol. Okay. And right before the loop plays out fully, we're going to actually set this variable to false. So first equals false. So that only on the first round from this loop, the first variable will be set to true. So that, I guess, any iteration afterwards, any iteration after the first one, this first variable will be set to false, okay? And now in the render function, we're going to write a condition so that if it's the first symbol, then we're going to set it to a color, to that special white-green color. So let's write our conditional. So if it's the first symbol, if it's first, this will evaluate down to true. Oh, sorry, we want to go inside this loop here. So if it's the first symbol, let's set it to a special fill. And if 255 is the maximal brightness for our RGB values, let's bring the red and blue up a notch. So let's say 180 for our red, green stays maximally bright, and 180 for our blue value. And if it's not the first symbol, well, let's proceed as normal. Let's fill it in just like everything else. Okay. And now, if we reload this thing, Okay, great. So there we have our effect. But I actually think it looks a little bit too excessive to have the tips of every single stream this bright. And in fact, if you look at the matrix, that's not the case. I would say like 50%, maybe even less, are colored this like special bright green color. So let's actually limit, let's go ahead in our code limit what gets this color. So for that first variable, instead of setting it just to true, I'm actually going to set it equal to this. I'm going to explain in just 1 second. Okay, so we're going to get a random number, either 0 or 1. And we're going to evaluate if this number is equal to 1. And if it is, this whole expression here, this whole thing, will get evaluated down to true. Otherwise, it gets evaluated down to false. So there's a 50% chance that this will evaluate to true. Therefore, there's a 50% chance that the first symbol in a given stream will be colored bright white green. Kind of like a coin toss, right? So let's go ahead and replay this now. Okay, great. So now 50% of these streams have a first symbol that is a different color. But even still, I think that 50% is too excessive, so let's go ahead, go back into our code, and maybe increase the pool of numbers that random can choose from. So let's say it's 4. So now there's a 1 in 5 chance that first will be true. So now there's going to be a lot fewer bright white first symbols. Okay, great. So I think that looks great. Okay. So I think we've now officially recreated our own version of the matrix digital rain in P5. Great. So I've put up my code on GitHub at this URL, if you can read it, in case you were sort of coding through and wanted a reference point. Just to keep in mind, however, that the code on my GitHub repo won't 100% reflect what is shown in this tutorial. It will mostly, but not 100%. And that's because my final version includes some finishing touches, extra finishing touches, and a few more creative decisions that I've made. And I sort of encourage you to do the same. Feel free to experiment, to play around, sort of inject your own creative decisions into this sketch. I mean, maybe you'll make the matrix purple, or maybe you'll make it rainbow, or maybe it'll be 3D, or maybe you'll have it scroll upside down. I don't know. I'm super excited, though, to see whatever you come up with and whatever direction you take this project in. Whatever the case, if you do make something cool, tweet it at me. And also, use this hashtag to share it with the rest of the P5 community. Because I think that's part of the fun, that's part of the beauty of P5, not just being able to make awesome artwork with code, but also being able to readily share it out on the internet, to share it with your friends or your family or randos on the internet like me. So anyway, I think that wraps it up for me. Thank you so much for watching. I hope you had a ton of fun. I know I certainly did. So yeah, thanks.